Hi all, I hope you enjoyed the animated video where I try to explain the concept of polling so that you will understand the interrupts better. In this particular video lecture, the topics that will be covered are what are interrupts more in detail, interrupt versus polling, terms associated with the interrupts, what are the interrupts present in 8051, and how to invoke or initialize interrupts in 8051 using control registers. Now before we go into this, I want to give you a general perspective of what an interrupt is and how to compare the interrupt scenario with the polling scenario. For this, I'm going to give you two scenarios so that you will be able to visualize what is an interrupt and what is a polling, and you will be able to decide better which one carries more weightage or pros and cons. The idea here is, imagine that you are a teacher and you have about 50 sheets to grade, answer sheets to grade. Now you also have a lab session to attend where you will be teaching 25 students of a class about certain experiments in microcontroller lab. Scenario 1 is, you go to the lab, explain to the students what that particular day experiment is and how to proceed with the experiment. Then you sit down in your table and start correcting your papers. Now you will keep continuing to correct your papers until a particular student or a group of students raise their hands, call you when they are stuck or they have some issues with the program or the execution of the program. At which point you will go explain or clarify their question, and once it is done, you will come back and again continue the process of grading your papers. I hope you have understood the scenario correctly. Now in this particular context, you are the processor or the controller. Your main task or one of the tasks is to grade your 50 papers, and each of these 25 students are 25 different subtasks that you have to take care of as well, apart from correcting your 50 papers. Now whenever a student raises a particular hand, raises a hand, or a group of students raise their hands to call you to get their doubts clarified, that is like somebody interrupting your work of correcting your 50 papers. Till a student or a group of students interrupt you, you will keep continuing to do your work of grading your 50 papers. And when such interrupt occurs, you will go service their interrupt by asking them what is the question and clarifying their question. Once that particular interrupt is serviced, you will come back and start doing your work again from where you left it off. This is scenario 1, which talks about interrupting your main task of correcting 50 papers or grading 50 papers. Now what is scenario 2? Scenario 2 is a bit lengthy process where what you decide is, you go to the lab, you explain everybody, all the students, what the experiment is and how to proceed, and then what you do is, you have a timer set in your watch for 10 minutes. So first what you do is, go to your table, start grading your papers for the first 10 minutes or for the duration of 10 minutes. Once the 10 minute is up, no matter whether you have graded your paper or not or completed the grading or not, at the end of 10th minute, no matter what, you stop correcting the papers. Then you go to the first student and check whether he has or she has any questions or doubts or clarifications. If yes, you clarify it. If not, you move to the next student, and so on till you reach the 25th student. Once you finish with the 25th student, you come back all the way to your desk, set the timer again for 10 minutes, and you start correcting your paper for the duration of 10 minutes. Now during this 10 minutes, even if some student calls you for a question, you will not get up to go and clarify that question. You will leave your desk only at the end of 10th minute. Now one more thing in here is, let's say during this 10-minute session, the 10th student calls you for a question. Even though you know the 10th student was the first one who called you for the question, at the end of 10th minute, you will not go directly to the 10th student, but again start from the first student, second, third, and go on till you reach the 10th student in a sequential order. or in any particular pattern that you have started with your first doubt question or clarification session. Now you will do this repeatedly till the lab session is over. Now scenario 2 is more related to polling, and scenario 1 is more related to interrupt. Now you think for yourself for a few seconds and decide which scenario as a processor or a controller would you prefer to cater to the needs of several devices that are present on the board or several tasks that you need to execute. Now some of you would have thought scenario 1, some of you would have thought scenario 2. Now which is right? Both scenario 1 and scenario 2 are correct. So irrespective of which scenario you have chosen, all of you are right. How is that possible? Though scenario 1 sounds better usage of time on the teacher's point of view, let us assume in scenario 1 we have a fact that, or we assume that all the students are brave enough or good enough to ask whatever question that arises in their mind in midst of other 24 students. This is the assumption we have in scenario 1. But what if there are some students who are afraid to ask questions in a group of class? Or there are several of us who have inhibition to ask questions in front of others. In that case, what do? If you go for scenario 1, you will answer only to those students who are good enough or brave enough to raise their hands and ask you questions. What about others who have questions and have not raised their hands? In scenario 2, every single student, whether they have a question or not, or whether they are good enough or brave enough to ask a question or not, will also be answered, as well as those who have inhibitions to ask in public. So in our second assumption, scenario 2 suits better, whereas in other cases scenario 1 suits better. Similarly, in a microprocessor or a microcontroller, we cannot outrightly say interrupts are better scenarios than polling, or polling are better scenarios than interrupts. It all depends on what kind of combination of devices that are present and what kind of tasks are present. Some are bidirectional tasks, some are unidirectional tasks, some are active, some could be active devices, some could be passive devices. So it all depends on what kind of combination you have along with your processor or controller to decide which are the ones that needs interrupt based control and which are the ones which needs polling based servicing. Now, what is an interrupt? An interrupt is an occurrence of condition that halts or pauses the normal flow of program. Let me repeat it again. An interrupt is an occurrence of condition or a type of condition or a type of scenario that halts or pauses or disturbs the normal flow of program. So what do I mean by normal flow of program? There is a main program which is in execution. For example, grading of your 50 papers. That is your main execution. So what is an interrupt here? A student raising his or her hand, or a group of students raising their hands. So that is an interrupt. So what is this interrupt doing? Disrupting, halting, pausing the normal flow of program, that is your correction or grading of your 50 papers. So what happens here when that interrupt occurs? As a processor, you stop what you are doing, you jump or go to that interrupt, look what is needed, service the interrupt, and return to the main execution, that is correcting your papers. So from this, what do we understand? Interrupts cannot be the main program. Interrupts can only be subroutines or smaller sections of the programs that needs to be executed by the processor only when the interrupt associated with the subroutine occurs. Until then, it need not be executed, or they do not form the main part of the main program. They are separate subroutines that needs to be written. Is that clear? Now, how many interrupts can we have? What are the different types of interrupts? We have software interrupt, we have hardware interrupt. How many interrupts can we have? Again, it depends upon the manufacturer or the architecture of the processor. It can be 1, it can be 5, it can be 6, it can be 10, it can be 20. It all depends on the architecture. Irrespective of whether it is a software interrupt or a hardware interrupt or how many interrupts we have, every interrupt that is being present in the processor must have a interrupt service routine. What is this interrupt service routine, or in short ISR? It's a small segment of code that needs to be executed whenever the particular interrupt occurs. So again, like your main code or assembly language program or C program, ISR is also a small segment of code which tells the processor or the controller what to do when that particular interrupt occurs. In general, it's a fact that interrupt saves precious CPU resources or CPU cycles, which we refer to as machine cycles. Definitely, interrupt saves precious CPU resources or cycles. So, when we analyze this statement, interrupts are best suited for a scenario where we have multiple tasks, like more than 5-6 time-based tasks that need to be controlled by the processor or the controller. Definitely in such situations, interrupts are a better choice than polling. Now, what about 8051? 8051 has 6 interrupts in total. So what are those 6 interrupts? Reset, INT0, INT1, TF0, TF1, RITI. This RITI is sometimes also called as serial communication interrupt. Reset. Now this has the highest priority in 8051 set of interrupts, and it is non-maskable too. What do I mean by non-maskable? You cannot mask this interrupt, in the sense whenever you assert this reset interrupt, the processor will always listen to this interrupt. There is no way you can make the controller or the processor not to listen to reset. That is what I mean by non-maskable. Now, what is INT0? That is an external hardware interrupt present in the 8051. T0 is the timer 0 interrupt, or TF0. Some books refer to as TF0, some books refer to as T0. This is nothing but timer 0 interrupt. INT1 is again an external interrupt, second external interrupt present in 8051. And T1 or TF1 is the timer 1 interrupt. And RITI or serial communication interrupt is an interrupt that generally can be used whenever you initiate serial communication between two 8051 microcontrollers or an 8051 and a PC. So these are the 6 interrupts. Now, as you see in the slide, each of these interrupts has their own vector address in the memory. So what do I mean by vector address? Now, whenever you press or assert INT0, the processor goes to the address 0003 and then checks for what needs to be done when this interrupt is asserted. So that is the memory vector address to which the processor will go and try to fetch the subroutine or the ISR or the instructions of what needs to be done when this interrupt is generated or asserted. Similar for T0, INT1, T1 and serial communication. Now what about reset? Since reset has the highest priority, its vector address is 0x0000. That's the starting point. So whenever you press reset, immediately the processor will go to that particular address and see what instructions are there that needs to be executed when reset is pressed. Is that clear? Understood? So these are the 6 interrupts present. We'll see in detail about what is this INT0 is, what is this T0, what does it do in the next video lecture. Now, having 6 interrupts, out of which reset is an exclusive category of interrupt. We will never discuss about reset because we all know what reset does, and since it is non-maskable, it will not be you don't have any kind of authority of enabling or disabling it. Again, that will not come into the picture. So whenever now we discuss interrupts with 8051, we will be talking only about those 5 interrupts, that is INT0, INT1, T0, T1 and serial communication interrupt. Now, how to assert or initialize or activate these interrupts? You have something called IE register in 8051, which is called as interrupt enable register. Now, as usual, this is an 8-bit register where if you look at the bits from LSB to MSB, as is indicated in the slide, it is very clear. EX is 0 stands for external interrupt 0 or INT 0. ET0 stands for timer 0. EX1 stands for INT1 or external interrupt 1 interrupt. Then ET1 is timer 1 interrupt. ES is for serial communication interrupt. The next 2 bits are reserved for future use, and EA is interrupt enable bit. Now, what are the functions of these bits? Let's say, for example, you want to activate the external interrupt INT0. So what you have to do is you have to write the appropriate number to this interrupt enable register. Can you guess what that would be? Always for activating you will write a 1, and for disabling or activating or enabling you will write 1, and for deactivating or disabling you will write a 0. So if you want to activate external interrupt 0 INT0, you have to write 1 on the LSB. If that is the only interrupt you want to enable, the rest of the interrupts you have to write 0 to make sure they are not enabled. Okay, the reserved always will have 0, so it will be 0 0. I'm talking from the 6th bit onwards. So 6th bit will be 0, 5th bit will be 0, 4th bit will be 0, 3rd bit will be 0, 2nd bit will be 0, 1st bit will be 0, and the 0th bit of the LSB will be 1. Now, if we do this, will the interrupt be enabled? No. Still we have the 8th bit called enable interrupt bit, which has to be asserted 1. If you write a 1 in that bit, only then this entire control register gets activated, and the 1 you write in the LSB makes sense. Even though you write 1 there, and if this 8th bit is 0, still it's not going to make any sense and the interrupt will not be activated. Consider it something like this. The 0th bit, 1st bit, 2nd bit, 3rd bit, 4th bit are all like your switches in your room, fan switch, light switch. And the 8th bit, the interrupt enable bit, is like the main switch. Only if the main switch is on, when you switch on the light, it will on, or switch off, the lights will go off. If the main is off, no matter how many times you switch on or off the lights or the fans, it's not going to work. So for any interrupt or any combination of interrupt, if at all you want it to work, definitely this enable interrupt bit, the 8th bit should be, MSB should be 1. Only then, whether you write 1 or 0 in a specific bits of these 0 to 4 will have some effect on the interrupts. So in order to enable the external interrupt 0 INT0 alone, to enable it, so the number that must be written in the IE register is 1 0 0 0 0 0 0 1. So either you can write this as a binary into the IE register, or convert it to an equivalent hexadecimal, and you can write it to the interrupt enable register. Now, depending upon what kind of interrupts you want to enable, you appropriately write it there 1 and zeros, and you find out the combination of that as a hexadecimal number, and you write that number, or you move that number into the IE register to activate that particular interrupt. Is that clear? So what all did we see today? Neither interrupt nor polling is best or worst. Each one has its own merits and demerits depending upon which scenario you want to use it in. 8051 has totally 6 interrupts, of which reset has the highest priority and is non-maskable. There are priorities associated with each interrupt, and when more than one interrupt is asserted, the processor attends to each interrupt in the order of their priorities. Always an ISR must be associated with each interrupt for it to perform certain additional functions. These are some of the important points that you need to remember when it comes to interrupt with 8051. In the next video, we will see in detail about what each interrupt is responsible for, what are the different priorities associated with each interrupts by default, is it possible to change these priorities, if yes, how, then how to write ISRs to add additional functionalities for each of these interrupts. Thank you.